So now let's move on to cross entropy and KL divergence. So what is cross entropy? The definition of cross entropy between distribution P and Q is this. The expectation with respect to x comes from random variable distribution P minus log Qx. So what is the meaning of cross entropy? So when you look at this part, the inside of expectation, it looks like an entropy. So what is the meaning of entropy? Essentially, in the entropy definition, the minus log px that basically indicate the ranks of code word you have to use when the ground truth distribution was p. So this minus log qx, this is the ranks of your code word when the distribution is q, not p. So this represents the codebook comes from distribution q. But here is the problem. We take the expectation with distribution p, not q. So essentially, we code our random realization with the knowledge on q, but in reality, the distribution was p. So this is the real distribution. So essentially, the cross entropy indicates the average amount of bit we use when we randomly generate the random sequence from the distribution P, but we use the codebook comes from the distribution Q. Then what is the KL divergence? KL divergence is expectation x from distribution P minus log Q x minus log px. So codebook of distribution Q, this is codebook of distribution P. And we take the expectation with distribution P. So this is essentially cross entropy between P and Q minus entropy of distribution P. So what is the meaning of KL divergence? This part is the amount of information of distribution P, and also this value is the amount of bit we have to use for sending our information from machine A to machine B when we know the true distribution P. So this is kind of optimal value. But this case, we code our random sequence using a false information, using a different distribution Q. So this is not optimal amount of bit. We can do better, but because we have wrong information, we spend more bit to send some information to machine B. So essentially, cross entropy always bigger than the entropy. So KL divergence always bigger than or equal to 0. And also, if the difference between P and Q is huge, then the amount of increase due to the wrong information will also very huge. So when the distance between P and Q is small, usually the cross entropy value will be close to entropy value, and then KL divergence value is also very small. Right? So that's why KL divergence is very nice indicator for assessing the difference between distribution P and Q. And the KL divergence between P and Q is equal to 0 if and only if the two distributions are the same. Okay. So in many machine learning algorithms, we use KL divergence or cross entropy as the loss function or cost function. Let's think this example. There's target distribution y, and in many cases there's just two output variable, so we can represent the output distribution vector with one hot encoded vector. There is only one element has value 1 and all the other elements are equal to 0. Let's say the index of this element is star. And there is some output of your algorithm that predict the ground truth variable. Let's say this is some probability vector comes from some softmax output. Okay, then the KL divergence between y, the true vector, and x hat, our estimation, is equal to, from the definition, cross entropy between y and x hat minus entropy of y. In this case, entropy y is equal to 0. When your random variable is deterministic, the entropy is equal to 0 from the definition. When your probability vector is one hot encoding, then the entropy is always 0. Okay? So the KL divergence is equal to cross entropy for this case. Even if y is not one hot encoding vector but some other probability vector like this, when there is fixed, this is a fixed target distribution, then entropy is constant, right? And you just control the x hat. When you control the parameter while you are running process, y does not change, but only x hat will be updated. So in that case, because the entropy part is just constant, we don't need to worry about entropy part. We just need to optimize the cross entropy part. That's why in many machine learning scenario, cross entropy is equivalent to KL divergence. Right, but this is not the end of story. Very recently, we have many applications where we can control the Y value as well. We can control the target distribution as well. In that case, because we can control the Y distribution as well, entropy is not constant. So from the parameter update, we can control the both cross entropy and entropy. In that case, KL divergence definitely a different term compared to cross entropy. So we have to carefully choose which one we have to use. Okay.